Hello viewers, welcome to Senior College Mathematics. Topic of discussion is vector algebra. Lesson 1, vector and scalar quantities. A vector is any quantity which has direction as well as size or magnitude. Examples of vectors are displacement or translation, velocity, force, acceleration, momentum, etc. The figure below shows a vector which moves from position A to position B. You have position A to position B. You have the vector A. The arrow is showing the direction of the vector. The vector in figure 1 can be written in many ways, either this or this. Since the points are on a Cartesian plane, AB can also be written as column vector or column matrix. That is, vector AB equal to vector A is equal to the column matrix with entries 4 and 1. Direction is important. Vector BA is in the opposite direction to AB, although they are both parallel and have the same size. So, vector BA, which is in the opposite direction to AB, is obtained by negating vector AB. Then you get vector BA. You have it in this form. If you open the matrix bracket with the minus sign, you have minus 4 minus 1. A scalar quantity has only magnitude. There is no direction. For example, the length of a ruler is 100 meters, but we do not associate any direction with it. Examples of scalar quantities are length, you have area, volume, mass, work, energy, distance, speed, density, thickness, calorie, time, etc. Displacement vectors. A displacement vector is a movement in a certain direction without turning. For example, in figure 1 above, AB, the vector AB is the displacement vector that takes A to B without turning. You can see the arrowhead, so the movement is forward. When there is no turning, we have a displacement vector. Free vector. Vectors may not necessarily have any particular position associated with them. Such vectors are usually called free vectors. When there is no position that can be associated to a given vector, it is called a free vector. Vectors which have particular positions associated with them may be located along a straight line or through a particular point. Consider town Q, which is 50 kilometers from town P in north 45 degrees east of P. So you have town P. You move to town Q, passing through town P in the direction of northeast. That is north 45 degrees east, and the distance is 50 kilometers. The vector 50 kilometers from P to Q in the direction north 45 degrees east can be represented by the line segment PQ. So you have vector PQ. In this respect, a vector can be regarded as a directed line segment. The directed line segment has initial point P and a terminal point Q. This is indicated by the arrow. You can see it here. So the start point initial, the end point, the terminal point. We said this is indicated by the arrow on the line segment PQ. The vector from P to Q as a directed line segment is written as vector PQ. So you see the arrow showing the direction from P to Q. Equivalent vectors. Figure 3 below shows a triangle ABC that is displaced or translated to triangle PQR. ABC to PQR. In figure 3, the displacement vectors AP, BQ, and CR all have the same size and direction. We say they are equivalent and write thus as vector AP is equivalent to vector BQ, equivalent to vector CR. Note that although the vectors have the same magnitude and direction, they have different points of application. Strictly speaking, they are not equal. Nevertheless, it is quite common to write vector AP equal to BQ, meaning that they are equivalent. Notice that vector AP, BQ, and CR are each equivalent to a movement of 3 units to the right. Let's explain that. Let's take AP. For instance, this is AP. If you trace this point down, you have 2. If you trace here down, you have 5. So 5 minus 2 is 3. So the movement is 3 units. Followed by a movement of 4 units upward. If you take AP also, if you trace here, here is 3, then you have 7. The difference is 4. These can be combined as a single column vector For example, vector AP is equal to the column vector with the entries 3 and 4. That is the right movement 3 and the upward movement 4. Negative vector. The negative vector of a vector A is the vector which has the same magnitude as that of A, but a direction opposite to that of A. It is very simple. The same magnitude, opposite direction. The negative vector of vector A is written as minus vector A. End of lesson 1. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.